Hello everyone, I hope this finds you when you are doing well. IBM is here with another episode of Learning Physics, and today I want to take you to I think this is part 3 of physical quantities, units and measurement techniques. I think in part 2 we stopped on page 13, and I want us to move to page 14. Let me reduce this thickness. I think around 15, 16 is enough. Okay, so on page 14, at temperature close to 0 Kelvin, the specific capacity C of a particular solid is given by that expression, where T is the temperature and B is a constant characteristic of the solid. The SI units of specific capacity is joules per kilogram per Kelvin. What is the unit of constant B expressed in SI base units? So we want the unit of constant B, so we shall make B the subject. B is going to be equal to C divided by T power 3. So C is, they told us at a temperature close to 0 Kelvin, the specific capacity C is given by that expression. And SI units for C are joules per kilogram per Kelvin. So this is joules. So I'll just put it, although I normally don't want to put equal signs on units. So this will be joules per kilogram per Kelvin divided by temperature in Kelvin units. So this is Kelvin power 3. Okay, so the only thing we need to change is joules. Joules is the unit of energy, is the unit of work done. So joules, 1 joule is equivalent to 1 kilogram, that is from kilogram meters per second square, that is for force, then times meters, that is for distance, because work done can be force times distance. So the unit joule is equivalent to kilogram meters squared per second squared. So this unit will be kilogram meters squared per second squared, then times per kilogram, then times per Kelvin divided by Kelvin power 3. So per kilogram was cancelled, and when K goes up, it becomes K power 4. So that means that it eliminates this one and this one. It becomes K power negative 4. So we have in the numerator, we have K power negative 4 upwards. Then we have M squared has remained, and S power negative 2 has also remained. So this means our answer, the correct answer here is going to be meters squared per second squared per Kelvin power 4, which is B. The speed of an aircraft in still air is 200 kilometers per hour. The wind blows from the west at a speed of 80 kilometers per hour. So the wind is blowing from the west. That means it's blowing towards the east at the speed of 85 kilometers per hour. In which direction must the pilot steer the aircraft in order to fly due north? So we want to fly due north. If the resultant is to be due north, then this pilot must steer the aircraft at an angle. Let's say the aircraft is coming from this side. So the aircraft must be steered at an angle. The speed of the aircraft is 200 kilometers per hour. So in which direction must the pilot steer the aircraft in order to fly due north? So because the pilot is aiming at going due north, then the aircraft must be at an angle. So since all answers we have east of west of north, it cannot be east of north. It can't be east of north because already we can see it is already on the west. So it is not. It can't be east of the north. So this one east is wrong. Even this one east of north is wrong. So we remain with west of north and west of north. So we just, since it is west of north, the angle is measured from the west. So that is the angle that we want. But we can find that angle by first of all finding this one here. I'll call this angle alpha. So adjacent hypotenuse, that is cos. So I can say that the cos of alpha is equal to the adjacent, which is 85, divided by the hypotenuse, which is 200. So I can first find alpha. So alpha will be equal to the cos inverse of 85 divided by 200. So alpha is 64. Alpha is 64.8. Alpha is 64.8 degrees. So I want theta, since it is measured west of north. West of north is measured from the vertical line. So theta is going to be 90 minus 64.8, which I think is 25.2, which is going to be D. We can check. 90 minus the answer, which is 25.15, which is 25.2 west of north. So the answer is going to be D. You can have a different way of doing it, there is no problem. A digital balance is used to weigh ingredients in a laboratory. When a weight is applied to the digital balance, an electronic circuit generates a current, which is then converted into a digital readout on the display. The electronic circuit gives a current 2.0 milliamperes when a weight of 30 newtons is applied, and a current of 0.5 milliamperes when a weight of 5 newtons is applied. Which calibration curve could represent this circuit? Okay, so we can check what is happening to the how the gradient, or how should the gradient be like. We can check that. I will start with a smaller value. Okay, I will start with a larger value of current when it is 2.0 milliamperes. What is the gradient of current against weight? What will the gradient be like? So at 2.0 milliamperes, the gradient is going to be 2 divided by 30, which is going to be 1 over 5. I think 1 over 15. 1 divided by 15 is 0. Okay, let me just leave it as 1 over 15. Then I will check the corresponding gradient of 0.5. At 0.5 milliamperes, the gradient is going to be 0.5 divided by 5. Let me check this. 0.5 divided by 5, that is 1 over 10. 1 over 10. And you notice that for large values of weight, the gradient is actually smaller. That means the gradient is decreasing. So it means the slope should decrease when the weight increases, because for smaller values of weight, you notice that the gradient is 1 over 10, and it is 1 over 10 is bigger than 1 over 15. That means as the weight increases, the gradient of the graph decreases. So I will simply say that the slope decreases. The slope decreases. How should I write this? So the slope decreases as the weight increases. So we have seen that. So the slope must decrease as the weight increases, because we have seen for small values of I and W, the slope is 1 over 10. And for a higher value of 2 milliamperes, the slope is 1 over 15, which is smaller than before. It means if we continue increasing the weight, still the slope will become smaller. This makes C wrong, because C shows that the slope is actually increasing. D is also wrong because the slope is increasing. And D is even wrong because it's showing that when the weight is 0, when the current is 2, the weight is 0. Then B is showing that actually the slope is decreasing, but it is showing that when the weight is 30, the current is not 30. The current is not 2 as given in the question, so this one is wrong. So the answer is going to be A. You notice that when the weight is 30, the current is 2, and the slope is actually decreasing. So this makes our answer to be A, because the gradient is decreasing and should be decreasing. Which unit can be expressed in base units as kilogram meters squared per second squared? I think this is automatically the joule. We can verify. The joule is a unit of work done, which is force times distance. And the force is mass. This is mass times acceleration, then times distance. Mass is kilogram, acceleration is meters per second squared, then times distance, which is meters, and that gives us kilogram meters per second squared, then this is also squared. And you remember the joule is a unit of work done, so 1 joule is the same as kilogram meter squared per second squared. The luminosity L of a star is given by that expression. Of course, you must have seen luminosity. Those who studied paper 4, you must have seen luminosity in astronomy and cosmology. What are the SI base units of L? L is the luminosity. So from this expression, 4 pi will not affect the units. The sigma is a constant whose units is given as watts per meter squared per Kelvin. So the units of L will be those of radius, which is meters squared, times sigma, which is watts per meter squared per Kelvin power negative 4, power 4. Then times temperature is power 4, so it will be again Kelvin power 4. So this one has already cancelled. Meters squared has also cancelled with per meter squared has cancelled with meters squared. So I remain with the watt. Now I have to change the watt. The watt is a unit of power, and power is equal to energy over time. At this point, if you are experienced, you know that energy can be work done. Work done is energy in motion. So the units of energy will therefore be kilogram meters squared per second squared divided by seconds. So this simplifies to kilogram meters squared per second power negative 3. And precisely when you look through our answers, the answer here becomes C. A particle has velocity v at an angle theta to the horizontal. The components of the particle's velocity are vv upwards in the vertical direction and vh to the right in the horizontal direction. What are expressions for the magnitude of v and for the angle theta? Expressions for magnitude of v and angle theta. Now note that v is the resultant velocity. So if I transfer v in the vertical to this point here, vertically upwards, so this is v in the vertical. So this will be right angled triangle. That means v squared is going to be equal to vh squared plus vv squared. So it is automatically plus. That means minus is out. So the minus part is out, but this should be under the square root. So v is going to be the square root of vh squared plus vv squared. So it means we still have a and b. Then the angle theta, this will be opposite adjacent, that is tan. So this is going to be tan inverse of the opposite, which is v in the vertical, over the adjacent. No, it is, yes, it is opposite of adjacent. So katoa. So it is vv over vh. So our answer is going to be precisely B. This is VV over VH. What is equivalent to 2000 microvolts? 2000 microvolts. So that is 2000 micro is times 10 power negative 6 volts. Okay. So 2000 microvolts, when I multiply this with my calculator, 2000 exponent negative 6, that is 2 times 10 power negative 3 volts, 2 times 10 power negative 3 volts, but 10 power negative 3 is milli, so this is 2 times, okay, 2 millivolts, so our answer is going to be B. What is the number of SI base units required to express electric field strength and power? Note that electric field strength has now been removed from AS completely. It is now a concept of A level. What is the number of SI base units required to express electric field strength? So electric field strength is defined as the force per unit positive charge. So the force has units. Of course, this is force over charge, which is I times T. We want in base units. So force is in kilograms, meters per second squared. Then current is in amperes and time is in seconds. So this is 1, 2, 3, 4. There are four for electric field strength. So that means we eliminate A and B. Why are they four? There is kilogram, there is meters, S becomes S power negative 3, and then there is per ampere. These are 4 units, 1, 2, 3, 4 base units. Then for power, we have already seen that power is equal to energy divided by time. And energy is having units as kilogram, meters squared per second squared, then divide by time, it becomes per second cubed. So this is 1, 2, 3 units. So for power, it is 3 units. So the answer is going to be D. The Planck constant H has SI units, joule seconds. Which equation could be used to calculate the Planck constant? So Planck constant is under quantum physics. So which equation could be used to calculate the Planck constant? Okay, so if we just look at the units, we don't need to know whether it is in A level or whatever. We just look at the units. So joule seconds is equivalent to joules is energy. So that is energy is now kilogram meter squared per second squared then times seconds. So this becomes kilogram meter squared per second. That is the unit. So which equation could be used to calculate the Planck constant? So we check the units. If they are equal, then it can be used. D is distance. Units, I'm checking the first equation. D is distance, which is meters. E is energy, so energy is kilogram meter squared per second squared. V is velocity, which is meters per second, so meters has cancelled. Then S power negative 2 divided by S power negative 1, so we are remaining with the kilogram meter squared S power negative 1, which is the same as that, so the answer is going to be A. Two cables are attached to a bracket and exert forces as shown. What are the magnitudes of the horizontal and the vertical components of the resultant force, the resultant of the two forces? The magnitudes of the horizontal and the vertical components of the resultant of the two forces. Okay, so let's find the horizontal. They are only going to act in towards the right in the horizontal. Resolving 15 to the horizontal, it will point that side, and to be 15 cos of 20. Resolving 6 to the horizontal, it also points that side, and to be 6, because the angle given is here, it will be 6 sine 40, or I can use this angle here, which is 90 minus 40, that is 50, so it can be 6 cos of 50 degrees. So because they point to the same side, I simply add them up. So in the horizontal, I'll call this, the forces in the horizontal will be 15 cos 20 plus 6 sine 40, or I will say 15 cos 20 plus 6 cos 50, which gives us 15 cos of 20 plus 6 sine of 40, which is 17.9, which is approximately 18. So that is 18 newtons, F in the X. So it means we have eliminated the A and B because the horizontal components are 9.7, 9.7. Then for the vertical component, these vertical components are going to be in opposite directions, so I have to subtract. So vertically upwards, this one points upwards and to be 15 sine of 20, and this one will point downwards and to be 6. If I use this angle here, it will be 6 cos of 40. So F in the Y is going to be 15 sine of 20. I will subtract because they're in opposite directions. 6 cos of 40. Don't mind about whichever is negative. the magnitude is what we are interested in here. So 15 sine of 20 minus 6 cos of 40. So I am getting 0.534. That means our answer is going to be C. So this is 0.534 newtons. So the answer is C. Which is an SI base unit? Current is a quantity, gram is not SI, Kelvin is the SI base unit here. The volt is not SI. Osmium, a naturally occurring element, has density 23,000. What is also a value of the density of osmium? Osmium, a naturally occurring element, has density 23,000 kilograms per meters cubed. What is also a value of density of osmium? So the density should be the same, but can be expressed in another quantity. Let's check. Micrograms per centimeters cubed. First of all, we can remove micro. So micro is going to be 22.3 times 10 power 4 times 10 power negative 6. To change it to kilograms, because it is in grams, I will multiply by 1,000 and I see if it is the same. So we have 2.3 exponent 4, then times 1 exponent negative 6 times 1,000. So this is 23 kilograms per meters cubed. So that is out. I will not check the others. This one just multiply by 1,000 and it is not. That one is out. This one is grams. It is kilograms per centimeters cubed. So it is 22.3 kilograms over centimeters cubed. I want to change from centimeters cubed to meters cubed. 1 meter is 1,000 centimeters. So if I want 1 meter cubed, I'll raise this to power 3. So it means 1 centimeter cubed is going to be 1 over 1 times 10 power, no, this is 100, not 1,000. 1 times 10 power 2. Then this is squared, cubed. So this is because this means this is in meters. This is going to be in meters cubed. So that means where there is centimeters cubed, I will put this value here, 1 over 10. Or I will put 1 over 100 power 3, which is 1 over 1, which is 1 over 1 million. So this will be 2.3 divided by, that is in kilograms, divided by 1 times 10 power 6 in meters cubed. So you notice that when I divide this, I will not get this. So this is out. Automatically, it means our answer is going to be D without even a station. We can check. So this one is going to be 2.3 times 10 power negative 2 in kilograms over 1 centimeter, which is 1 times 10 power, 1 times 10 power, actually this is power negative 6, because it is 1 centimeter cubed is 1 over, so that is negative 6. So this is negative 6. So we can check 2.3 exponent negative 2 divided by 1 exponent negative 6. So it is 23,000. So this is going to be the correct answer. And this one is not going to be correct. Two tugs are towing an oil rig as shown. The tensions in the towing cables are 4.0 kilonewtons and 5.0 kilonewtons. What is the total force acting on the rig due to the cables in the direction to the east? So to the east, they will all point to on one side, so we shall just simply add. So the total force to the east is going to be resolving 4 in the horizontal, that will be 4 cos of 20 plus resolving 5 to the horizontal, that will be 5 cos of 50. So this is 4 cos of 20 plus 5 cos of 50. So that gives us 6.9, which is approximately 7.0 kilonewtons. So our answer is going to be C. What is the approximate kinetic energy of an Olympic athlete when running a maximum speed of 100 meters? I think we have answered this question already, and the answer is B. You just check, remember, kinetic energy is equal to a half times the mass times v squared. We estimate that an athlete running, even if he's running very fast, v is about 10 meters per second. So we try to check the mass. The mass is going to be 2 times 4,000 divided by 10 squared, which is going to give us 80 kilograms. So this is a reasonable mass for an athlete, so the answer is B. You can check the other values, but the answer is B. The diagram shows the reading on an analog ammeter. Which digital ammeter reading is the same as the reading on the analog ammeter? Okay, so the reading is the scale here is giving us, this is 1, 2, 3, 4, 5. So this is 2. It means each division is going to be 2 divided by 10, which is 0.2. So the reading is, each division is 0.2. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 0.2, the reading is 8 times 0.2, which is 1.6, I guess, milliamperes, because the scale is showing milliamperes. So now we can check. They are saying 1,600 microamperes, which we can check 1,600 microamperes. When I remove the micro, I multiply by 10 power negative 6. So this is 1,600 times 10 power negative 6. 1,600 exponent negative 6, which is 1.6 times 10 power negative 3 in amperes. But remember, 10 power negative 3 is micro, so this is 1.6 milli. So this is 1.6 milliamperes. So the answer is going to be A. The table shows some measurable quantities. Which row gives the correct order of magnitude of the measurable quantity in the stated unit? So which row gives the correct order of magnitude of the measurable quantity in the stated unit? Okay, so let's check. The mass of a coin, 10 power negative 4 in kilograms. Let's check 10 power negative 4 in kilograms. This is the same as, we can try to multiply by 1,000. 1 exponent negative 4. This is 0.1 gram. This is too small. That coin cannot exist. 0.1 gram. Then the thickness of a paper is 10 power negative 2 in meters. Let's check. 10 power negative 2 in meters is the same as, I will change it to centimeters. 1 exponent negative 2 times 100, change it to centimeters, it is 1 centimeter. There is no paper which is 1 centimeter thick unless it is, look at your ruler in the set ruler and see the thickness of 1 centimeter. Compare with the papers you normally interact with. This is very big. Even if it is a hard cover, it is still very big. The weight of an apple is 10 power 0 newtons. 10 power 0 is the same as 1 newton. I think that makes sense. 1 newton. Remember, weight is mg. We can try to find the mass. So the mass is going to be the weight, which is 1, divided by g, which is 9.81. So I'll multiply this by 1,000 to change it to grams, so that I can see whether it makes sense. So 1,000 divided by 9.81. That is around 100 grams, so it makes sense. A mass is about 100 grams. I think an apple can have a mass of approximately 100 grams, so this one is correct. The temperature of a person's body is 10 per 1 Kelvin. 10 Kelvin is the same as 10 minus 273. So this one gives us a negative value in degrees Celsius. It is approximately negative 263 degrees Celsius. This is too small. The normal human body is around 25 degrees Celsius. So this is, okay, room temperature is 25. The normal body can be around 35, 36 degrees Celsius. So this one does not make sense. A byte comprises 8 bits. How many bits are there in 1 terabyte? So 1 terabyte. So we remove tera. 1 terabyte. So this is 1 times 10 power. Tera is power 12. So it is 1 times 10 power 12 bytes. So tera is 10 power 12. So we ignore this one, 10 power 9, 10 power 8, 10 power 9 we ignore, so we have this one. But remember, a byte has 8 bits, so the answer is going to be D. Which pair of quantities contains both a scalar and a vector? And one scalar, one vector, these are both vectors, these are both scalars, these are both scalars, so the answer is D. Temperature is a scalar, velocity is a vector. What is a reasonable estimate of the kinetic energy of a car traveling at a speed of 30 meters per second? So that one is very easy. We try to find the mass. We check, I'll only check one, I'll check C, because I think C is approximately the correct answer. So kinetic energy is 10 power 6 equals to a half. The mass, I'll call it M. The speed is given as 30 but squared. So let's find M. So it will be 2 exponent 6 divided by 30 squared. So that is giving us a value of approximately 2000. So mass is approximately 2000. I think a car can be 2000 kilograms. So the answer is going to be C. You can check these other values. They will give you these ones will give you very small mass of a car. This could even be less than that of a person. We can check. Let's check A. A will be 2 exponent 2 divided by 30 squared. It is even smaller than the mass of it is too small anyway. 10 power 4, we have 2 exponent 4 divided by 30 squared. It is still small. It can't be mass of a car. So I'm multiplying by 2 because I'm making M the subject in this equation here. So that's why I say 2 times 10 power 2. 2 times 10 power 4. Then I divide by 30 squared to make M the subject. The frequency F of vibration of a mass M supported by a spring with a spring constant K is given by that equation there, where C has no units. What are the values of P and Q? So C has no units. Frequency has units as S power negative 1. So this would be C has no units. We have M is mass. So mass is kilograms power P. And K is the spring constant. So we have K power Q. For spring constant from Hooke's law, K is equal to F over extension from Hooke's law. So the units of K will be for F which is kilogram meters per second squared divided by extension which is meters. So this one cancels. So S power negative 1 is equal to kilograms power P times K, which is kilogram S power negative 2. And this one is raised to power Q. So on the left hand side, S is raised to power negative 1. On the right hand side, S is raised to power negative 2Q. Which means that if I equate the powers, Q is equal to a half positive. So Q is positive. We ignore A and C, because those ones are saying that Q is negative. Then for P, on the left hand side there is no P, so I'll put there 0. S, I can say, let me say kilogram power 0 on the left hand side is equal to kilogram. On the right hand side I have power P. We add the powers, kilogram power Q, so it is plus Q. So P plus Q is equal to 0. P plus Q should be equal to 0. But remember Q is a half. That means P is going to be negative a half. So P should be negative a half. So the answer is going to be B. The power produced by a force moving an object is given by the equation shown. Which quantities are scalars and which are vectors? So this is a vector, scalar. Scalars displacement is not, force is not. So C and A are out. Vectors, work is not a vector, so our answer is going to be B. Work is a scalar quantity. What is a reasonable estimate for the mass of a raindrop? The mass of a raindrop. So I think the mass of a raindrop is approximately 10 power negative 5 kilograms. Why? Mass is equal to density times volume. If we assume that of course the density is going to be that of the water approximately, the volume is going to be 4/3 pi r cubed. If I estimate the radius of a raindrop, it is very small. It is actually less than, it's almost less than 1 millimeter, but I will just take 1 millimeter. So this will be 1,000 times 4/3 times pi, then times, I'm estimating the diameter to be approximately 1 millimeter or just 1 millimeter as radius. So this is 1 times 10 power negative 3 raised to power 3. I've estimated the radius to be approximately 1 millimeter, but it could be even smaller. So I'm now computing. I'll start with the bracket. 1 exponent negative 3. This is power 3. Then times 4 times pi divided by 3. Then I can multiply this by 1,000. So I'm getting this approximate as 4.18 times 10 power negative 6 in kilograms. So it means these ones are very big values. So the answer which is closest is 10 power negative 5. Which quantity is a scalar? Vector, vector, vector. The answer is C. A galvanometer of resistance 5 ohms is to be used in a null method. Remember, the null method, a measurement is correct when the instrument reads 0. So the measurement will be correct when the galvanometer reads 0. In order to protect the galvanometer from damage due to an excessive initial current, resistors of resistance 0.5 and 1 kilo ohms are available. Which arrangement would provide this protection? So we want to reduce the initial current. That means we need a greater resistance. Let's see. 0.5 resistance in series with the galvanometer. Of course, 0.5 in series with the galvanometer, it is still very small, of course. So this one, total resistance increases, but it is still very small. 0.5 resistance in parallel with the galvanometer. So 0.5 resistance in parallel with the galvanometer. That one increases the total resistance because this is 0.5. If it was a whole number, then it would decrease. So 0.5 in parallel with the galvanometer, that one increases the resistance. This combination is placed in series with 1 kilo ohms, again resistance increases. So this one will give minimum current because 0.5 in series in parallel with the galvanometer, it makes the total resistance greater because of the 0.5. If it was a whole number, the resistance would be smaller. Because for parallel combination, resistance is equal to total resistance is a product over sum. We can even check. So we shall have here 0.5 times 5 over 0.5 plus 5. So total resistance will be 0.5 times 5 divided by 0.5 plus 5. So this is a value of resistance which is 0.45, actually 46. By the way, it reduces the resistance, but then this combination is placed in series with 1 kilo ohm, so we just add plus 1 kilo ohm, that is plus 1000. So total resistance here is higher. 1 kilo ohm in parallel with the galvanometer, that will be 1000 times 5 over 1000 plus 5. This value is less than the other one. So it means the current here is smaller than the current here. 1 kilo ohm in parallel with the galvanometer, that gives us this value. And then in series with 0.5 ohms. So we get this value here plus 0.5. This value is already less than that one, the one we got above. This one was 1000 plus 0.47. Sorry, it is 46, I think. Yes, 0.46. So that means this value here, 1000 times 5, that is 5000 divided by 1005, which is already very small. So this is 4.8. 4.8. So this one is a small resistance. It will give a bigger current. Then so on this one, on this 4.8, we are adding 0.5, which is still very small. So the answer is going to be B. A man is running in a race in a straight line. What is an approximate value of his kinetic energy? So we look for a value that gives us a mass close to the reasonable mass of a man, and I think the answer is C. Kinetic energy is 1000. This is equal to a half times the mass of the man. We can estimate the speed. Let's say the man is running at 10 meters per second. So this is 10 squared. So we can check 2 times 1000 divided by 100. So that is 20. So I took a speed of 20. So the mass here is 20 kilograms. But it is a man running a race in a straight line. Let's check the 10,000. So it will be 2 times 10,000. I chose the speed as 10, but that is a very big speed. So 2 times 10,000. 2 times 10,000. Then I divide this by 10 squared. So this will give us 200, and there is no such a man of 200 kilograms. So it means the answer is going to be that one. Okay, so we agree that it is unlikely that somebody who is running a race has a mass of 200 kilograms. So that's what makes this one wrong. This one again, the mass will be too small. This one will be too small. So the answer is going to be C. Perhaps the choice of speed is what made this to be very small, 20 kilograms. A sample of gas has a mass of 4.8 micrograms and occupies a volume of 1.2 decimeters cubed. What is the density of the sample of the gas? So density is mass over volume. So I'll change everything. So I'll change the mass to kilograms, so that will be 4.8 times 10 power negative 6 to remove micro, times 10 power negative 3 to change it to kilograms. Divide by the volume is 1.2. I will remove this. This is times 10 power. This is times 10 power negative 1. Yes, times 10 power negative 1. So I'll press my calculator. 4.8 exponent, I'll just say negative 9. Divided by 1.2 exponent negative 1. So this gives us 4.0 times 10 power negative 8. Is it? 4.0 times 10 power negative 8. Let me check it again. Decimeters cubed. Sorry, this is decimeters cubed, not decimeters. So this is 1 meter is going to be equal to 1 is equal to 1 decimeter is equal to 1 over 10 meters. Now if it is decimeters cubed, it will be this one cubed. Yes. So 1 decimeter cubed is going to be 10 power negative 3. So this should be negative 3. 10 power negative 3 meters cubed. Yes. So this will be, so the answer is going to be C. Precisely the answer is C. 1 decimeter cubed is going to be 1 over 10 meters, but this is power 3. So 1 decimeters cubed is going to be equal to 1 over 10 power 3 is going to be 10 power negative 3 meters cubed. So this is going to be 4.8 exponent negative 9 divided by 1.2 exponent negative 3, which is 4.0 times 10 power 6, 4.0 times 10 power negative 6 kilograms per meters cubed. So the answer is going to be C. Which characteristics are possessed by a vector quantity but not a scalar quantity? So remember, both of them have magnitude. So direction only, unit only, possessed by a vector quantity but not a scalar quantity. So the answer is going to be A, because a scalar quantity does not have a direction, but a vector quantity has direction. So these ones are wrong. The vector quantity has direction. Direction is the only quantity which is not showed by a scalar quantity, but magnitude, a scalar also has magnitude, it also has a unit. A circuit is set up in order to determine the resistance of 12 volts 1.2 watt lamp when operating normally. An analog ammeter and an analog voltmeter are used. Which ranges for the meters would be suitable? Okay, for voltage, let's check the current. Current is going to be equal to power divided by V, because power is IV. So this is going to be 1.2 divided by 12. 1.2 divided by 12, that is 0.1 amperes. So it means the current is in the range 0 to 0.5, meaning C and D are wrong. And notice that the value of V is in the range 0 to 20, so the answer is going to be A, because current is 0.1 and V is 12 volts, so this is between 0 and 20, so the answer is A. Which quantity is a physical quantity? Remember, a physical quantity is the one which has which can be expressed with as a numerical magnitude with a unit. So atomic number has no units. Efficiency is a ratio. Number density of charge carriers. Number density of charge carriers. This one is charge per unit volume. Strain has no unit, so the answer is C. C has units, number density of charge carriers, that is number of charge carriers per unit volume, which is the unit is going to be per meter cubed. Which time interval is the shortest? We can convert these ones, but I think the answer is going to be B, because when I convert 50 times 10 power negative 9, because nano is power negative 9, that is 5, that is too small a value. So it will be 5 times 10 power negative 8. So this one is very big. This one, milliseconds, is going to be 0.05 times 10 power negative 3 seconds. This is bigger than this one already. Micro is going to be 0.5 times 10 power negative 6, which is 5 times 10 power negative 7, which is still bigger. So the answer is going to be B. P and R are coplanar vectors. If X equals to P minus R, which diagram best represents vector X? So X can also be this vector here can also be written as X plus R equals to P. We can also check that one. X plus P. Remember, when two vectors are added and they form one loop in one direction, the resultant is in the opposite direction. So if I say X plus R, that is clockwise, the resultant is P, which is anti-clockwise. So I think this is correct. If I say X plus P, this one we don't have X plus P. This is X plus P is equal to R. This is out. So this one is automatically wrong. This one is R plus P is equal to X. This one we don't have it, so the answer is going to be A. X plus R is equal to P. If X is added to R, it forms one direction, then P is the other way around. So the answer is A. What is a reasonable estimate of the volume of a fully inflated standard football? Fully inflated, that is when it has been pumped to the fullest. And I think the answer here is most likely going to be B. We can check by estimating. We know that the volume is going to be 4 over 3 pi r cubed. We are going to estimate the radius using these volumes. I will check B. You can check the rest. So if B is 600,000 centimeters cubed, it will be 4 over 3 pi times r cubed. I'm finding r in centimeters cubed in centimeters. So this would be 3 times 6,000 divided by 4 pi. Then I get the cube root. So this is giving me r as 11 point something, approximately 11 centimeters as the radius. This makes sense for the radius of a ball to be 11 centimeters. So when I use this one, the radius is going to be very small. When I use this one, it will be very big, it will be very big. So the answer is going to be B. What is not an SI base unit? Not SI base unit. The column is not an SI base unit. Kilogram is SI, Kelvin is SI, seconds is SI. So the answer is going to be A, not an SI base unit. Which two quantities are both vector quantities? This one is scalar, force is vector, momentum is vector. The answer is B. A calibration curve is shown for an ammeter whose scale is inaccurate. Two readings taken on the ammeter at different times during an experiment are 0.13 and 0.47. By how much did the ammeter really increase? By how much did the ammeter reading really increase? So notice that the scale on the vertical is 0.1 divided by 5, which is 0.02. So the scale here is 0.02. One small box is 0.02, even on the x-axis. Okay, so 0.13, let's check 0.13. This is 0.12. 0.13 is in the middle here. 0.13 is in the middle there, which is giving us this value. This value is 0.14. Then 0.47, so this is 0.4244. This is 4647 is in the middle of this box here. .47. This is 442, 4446. 47 is approximately here. which is giving us 0.44. So this is 0.44. So the question is, by how much did the current really increase between taking the two readings? So we shall simply get 0.44 minus 0.14, which gives us, I think this is 0.30. So the answer is going to be A. Since we were finding the change in the current, I did not even bother about the zero error on the vertical. A student uses the volume of a metal coin in order to determine the density of the metal. What is not needed in order to determine an estimate of the volume of the coin? So volume of the coin, because it uses the volume of a metal coin in order to determine the density of the metal. What is not needed in order to determine an estimate of the volume of the coin? I think the mass is not needed. We don't need the mass, because what we need is the diameter and the thickness to find the volume, because it will be kind of cylindrical. It will be kind of cylindrical. Okay, I think we can stop there for this part. We shall begin from there in part 4. I think you have learned something from this, and bye bye. Have a blessed time.